You're welcome to Explore Insights. In this video, I want to teach on how you can view the switch MAC address table. So let's begin by setting up the network topology. So in this scenario, we are to use two switches and two PCs, which are PCA and PCB, and X1 with S2 with copper straight cables. So we are using 3 copper straight cables as seen here. So let's implement that using the Cisco packet tracer. So you'll see over here, we have the switch. So I'll take one switch and paste here. And paste here. Then I'll take the second switch and paste here. Then we go over to take for the pieces. So I'll take the PC here and paste here. Take another PC here and paste here. Then for our copper straight through, we're going to take from here. You go to connections and click on copper straight through, which is here. So click on it. Now take note of what we are asked to do. We are asked to connect from here using the fast Ethernet 0/6 to fast Ethernet 0. So we'll take from here fast Ethernet 0/6 to fast Ethernet 0. The same we are going to do for X2, but this time we are going to take fast Ethernet 0/18 seen over here to PCB, and we're going to use fast Ethernet 0 likewise. Now the next network connection, which is switch 0 and switch 1, we're going to use the same copper straight through here, and we will connect from fast Ethernet 0/1 to fast Ethernet 0/1. So let me give a pause. If you're just joining this video for the first time or this channel for the first time, do not forget to like, share, and subscribe to this channel. Thank you for coming. So let's continue with what we have. So now this tells us about our addressing table towards here, and we have X1, S2, PCA, PCB. Now, if you go over to our objective, one is to build and configure the network, and the second is to examine the switch MAC address table. So the next thing you need to see through is the background scenario. And in the background scenario, you can see all the details rightly written here. You can see what we have in the background scenario. You need to know that the purpose of the layer 2 LAN switch is to deliver Ethernet frames to host devices on the local network. So the switch records the host MAC addresses. That means the source and the destination MAC addresses that are visible on the network, and map those MAC addresses to its own Ethernet switch port. This process is called building the MAC address table. Then when a switch receives a frame from a PC, it examines the frame source and destination MAC addresses. So you could read further to get all what we are trying to do in this lab exercise. So also note that the switch are used to interconnect and deliver information to computers on LAN local area network. Switches deliver Ethernet framework to frame devices identified by network interface card MAC addresses. So I just want to move quickly so I don't make this video lengthy. So let's look at the required resources. So we just need 2 switches, 2 PCs, the console cable, the Ethernet cable. Okay, so which some of it you can see over here. Now the instructions, we'll be following through the instructions. So for part 1, we are to build and configure the network. So the step 1 is to cable the network according to the topology, which we have done right here. Now the next thing we need to do is to configure the PC host. how do we configure the PC host, which is step 2. You need to quickly look at the address table. So let's go forward to look at the address table. So if you look here for the PCA and PCB, this is the IP address we'll be configuring when we go to IP configuration on the Cisco packet tracer. Meanwhile, for the subnet mask, we don't need to do that because it does that automatically. So follow me to PCA. So let me rename this to PCA. So we have PCA, and this one, we have it as PCB. And this one, we'll call it S1. So we'll give this one S2. So if we want to configure the IP address for PCA, we'll click here. And then we go to desktop as seen here. And then go to IP config, which you can see here. Then type the IP address, which we have as 192.168.1.1. You don't need to put the subnet mask. It will do that automatically by clicking. Okay, so we'll move over to PCB. For PCB, we're going to give the IP address. Come to IP configuration. Then we have 192.168.1.2. So having done that, we'll proceed to the next step. So the next step said we should initialize and reload the switches as necessary. So just in case if your switches has been configured before, so you need to reload it. So let's see, how do we go about that? You go to S1, then you click enter. When you click enter here, you press EN, enable. And the next thing you need to do is to write erase startup config. Sorry, that hyphen is not supposed to be there. You say erase startup config. Okay, so this is what you're going to type and press your enter key. So it will ask you erasing the NVRAM file system will remove all configuration file. Yes, so this is what we want, to press the enter key to confirm and to tell us that it has been erased. Then we reload, because we have to do two things. The first one is to initialize and the other one is to reload. So let's reload. So proceed with reload. You click on enter and this is what you're going to have. So we've done that for S1. Let's do the same for S2. Then reload. So while it's taking on that, let's see the next task. Now in the next task, we have step 4. In the step 4, it says we should configure the basic settings for each switch. So what do we need to do? First A said we should configure the device name as shown in the topology. And then once we're done with that, we'll give the IP address for the switch. So we are doing for each switch, so S1 and S2. And we go ahead to put the password. For the password, we're going to set that as Cisco for both the console access and the VTY. And then for the privilege, we're going to write it as class. So let's go straight there to do the following. So we are going with task 1. So the first thing we need to do is the host name. So this is task 1. So on task 1, we are doing the following. The first thing to do is the host name. So we give the host name S1. And then, so we need to get to the configuration mode. Pardon me. So we click EN and then config T. And then the host name, because we are supposed to assign the name according to the addressing table, S1. So having done that, the next is to put the IP address by going to the interface configuration mode. So we have interface VLAN 1, and then we type in the IP address as 192.168.1.11. Then 255.255.255.0. And the next thing we need to do is to say no shutdown. So having done that, the next thing is to go about our password. So in our password, we have to do that on the configuration mode. So we have to exit from the interface configuration mode to the configuration mode. So with exit, we go back. So we move from interface configuration mode to configuration mode, which you can see here. Now, let's put the password for the line console. So we say line console 0. And then we put the password, which is Cisco. And remember to put the login just to activate the password we've put in, and then you exit. And the next one we need to do is for the VTY, line VTY. So together we need to say line VTY 0 to 15. So the next thing is to put the password. We have it as Cisco. And then we move over to, first we'll exit before we do that for the privilege password too. So let's exit. And then for the privilege, we say enable password. This time the password is class. So take note of that. And then we exit. So being able to fulfill that task. Let's replicate the same for S2. We've done for S1. So we need to do for S2. Now for S2, we have enable. In enable, we have to put the host name, but we have to do that on the configuration mode. Take note, I'm trying to configure for S2. What I did in S1 is what I want to replicate for S2. So we move over to the configuration mode from the privilege mode, and we type hostname S2. So it will change the switch here to S2. So the next thing we need to do is to go and fix in our IP address. We'll do that in the interface configuration mode by typing interface VLAN 1 and then say IP address 192.168.1.12 space 255.255.255.0, and then you say no shutdown. So having done that, let's exit. Now let's go ahead to put the 3 passwords we need. The first one is the line console, the other one is the VTY, and the other one is the privilege mode. So for the line console, we just have to say line console 0, which will take us to the interface configuration mode. And then we'll put the password for that, which is Cisco. Having done that, we have to log in to activate that password. And then we exit. Then we do for line VTY. We just have to type line VTY 0 to 15 to activate line VTY. Then we'll type the password Cisco. We need to exit from here to get us to the configuration mode by typing exit. Then for the privileged password mode, we need to say enable password. And remember, the password we are asked to put is class. We exit. Okay, so we'll be able to do for that of S1 and also for S2. So let's try and see what is the next task. So we finish step 4 of part 1. We'll move over to part 2. So take a look at part 2 and see what we are asked to do. So we are asked to examine the switch MAC address A switch learns MAC address and views the MAC address table as network device initiates communication on the network. So first, in part 1, we are to set the record network device of the MAC addresses for both PCA and PCB. So you need to fix in what can you see in PCA MAC address and what can you see in PCB MAC address. So how do you get this MAC address from PCA and also from PCB? You need to just type the code ipconfig space \o, which is here. Okay, so let's go to PCA and PCB. So I'm here. I'm going to click on PCA. So once I get here, I'll close this IP configuration and then go to my command prompt over here. And when I get to my command prompt over here, I'm going to type ipconfig space \o. Take note, I'm actually on PCA. Now type in your enter key and look for your MAC address. Absolutely, if you look here, you're not going to see anything like MAC address. So let me notice that in MAC address, we have other 3 names that can replace the MAC address. So you can call it the physical address, you can call it the hardware address, you can call it the Ethernet hardware address. So in this case, what can you see out of the 3 names I've listed that could replace MAC address? You could see physical address. So what is the physical address for PCA? So you have that as 0000164DE.0DDDE. Remember, why is it this way? It's because MAC address has 48 bits. So that's to give about 8 bytes if you have to convert the bit to bytes. So for what you got in the MAC address PCA, you paste the answer there. Take note, it might not be the same with my own. So I'm just going to write the answer 001.64DE.0DDE. Okay, so this is what I have. So check out what you've gotten for your own too. Now for PCB MAC address, the same thing we did. Let's check for PCB. So for PCB, you close the IP configuration, you come to command prompt, and then you say ipconfig space \o. Type in your enter key, and what can you see? From the physical address, you can tell the MAC address of the PCB. So fill up that question with the given answer you've gotten. So I'm going to write that as 0001.97C0.CB5A. So that is what I've gotten for my own. Okay, so let's go to the next one. Now console into switch S1 and S2 and type the show interface F0/1 command on each switch. So we are supposed to console. So let's carry on with the console. You come to the console cable over here. That's the second cable from the left. Then you click from the switch. You click from the switch. You click on console down to the PCA and you take RS232. So the same thing I'm going to do for S2 and PCB. So I'll click here, console, and come over here and take RS232. Now, having done the console configuration for S1 and S2, let's go in and type the show interface F0/1 command on each switch. Now, if you want to do that from the PCA, you go to the terminal and click OK. So from the terminal, you see show interface F0/1. Now see the information you're going to get. Now take note that in this situation, you found the name to be hardware. So this is what you're going to see as 00D0.5545.B101. So the report you've gotten here is what you need to type and answer here. So I'm just writing my own. So if you see yours, do where to write it out. FF45.B101. Now check the same by going to PCB. You can get for S2. Go to the terminal, click OK, and also you can see S2 there, right there. And then you say show interface F0/1. Now, which information do you have? So you write it down. This is what you have here. You write it down. So I'm writing mine down. 0001.64B5.C101. Okay, so this is what I have here. Okay, so having answered this, let's go to step 2. So for step 2, this is to help us display the switch MAC address table. Now you console into switch S2 and you view the MAC address table both before and after running the network communication test with ping. So we'll establish a console connection to S2 and enter the privilege exec mode. Now when we enter the privilege exec mode, we are going to say show MAC address table. So let's do that. You use your backspace here, and remember we are to check show MAC address table. Okay, so what do you get? You can see you have this table, right? Now good. Now do the same. Okay, for this case we are doing for S2, so you can replicate the same for S1 just to have an idea of the MAC address table. So it says here, even though there has been no network communication initiated across the network, that is no use of ping, it is possible that the switch has learned MAC addresses from its connection to the PC and the other switch. Are there any MAC addresses recorded in the MAC address table? I think we've gotten only one, which we can see here. So you can see that this is the only MAC address we have in this case. So what MAC address are recorded in the table? To which switch port are they mapped to, and to which devices do they belong? Ignore MAC addresses that are mapped to the CPU. So if you ask me that, you're going to see the MAC address recorded in the table, and it also tells the port. So the port we have here is Fast Ethernet 0/1. And also it is VLAN 1. So let's go to the other one. So this is for S1, this is for S2. So you take a screenshot and display your S2. Let's do the same for S1. So I will go to PCA to get for my S1. So right here, I'm going to say show MAC address table. Enter. So show MAC address table. You will see this one we have here. Fast Ethernet 0/1. Okay. Okay, so we have something here. If you have not previously recorded MAC addresses of network device in step 1, how can you tell which device the MAC addresses belong to? Using only the output from the show MAC address table command. Does it work in all scenarios? Okay, so we have something here you should give a thought to. If you have not previously recorded MAC addresses of network devices in step 1, how could you tell which devices the MAC addresses belong to? Using only the output from the show MAC address table command, does it work in all scenarios? So give this a thought and give a feedback on that. So you could drop it in the comment section. Now let's go to step 3. Clear the S2 MAC address table and display the MAC address table again. So let's clear. How do we clear? We need to type this, clear MAC address table dynamic, and then press enter. So let me do that on S2. So I'll come here and say clear MAC address table dynamic. Now we are asked to quickly type the show MAC address table command again. So let's quickly type that, but you don't need to type it, just use your forward arrow and it will bring what you've typed before. Show MAC address table, you can see what we have, which is previously like the former time we typed that. So it asks, does the MAC address table have any addresses in it for VLAN 1? Are there other MAC addresses listed? No. So what can you see? So wait for 10 seconds, type the show MAC address again and press enter. Are there new addresses in the MAC address table? New, no. So in both cases, we have no, no, no. So let's move to step 4. Step 4 says, from PCB, ping the devices on the network and observe the switch MAC address table. So what do? We go to PCB, open the command prompt and type ARP space hyphen A. ARP means Address Resolution Protocol. Okay, so let's go to B. So remember, you have to close the terminal and go to command prompt to do that. We have to type the backspace and then say ARP space hyphen A. Now what are you going to see? No ARP entries found. So let's see, not including multicast or broadcast addresses. How many device IP to MAC address paired have been named by ARP? What we saw is no ARP entries found. Okay, so the next one we have is from PCB command prompt, ping PCA S1, S2. So we have here from B command prompt, ping PCA S1 and S2. So what does that mean? It means that we are going to ping the addresses. So if we are to ping for PCA, it means we are supposed to ping 192.168.1.1, and for S1, we're supposed to ping 192.168.1.11, and for S2, we're supposed to ping 192.168.1.12. So this is what we are going to get. So let's go ahead to ping that in B. So I'm pinging straight away, starting with PCA. So we have 192.168.1.1. Okay, now it says, did all devices have successful replies? If not, check your cabling and IP configuration. So let's ping all of them. So I'll ping and press enter. So you can see that this goes successfully. And once we have that, I'll ping again for the next one. And this time we'll be working on S1. So we'll put 11. And then we ping again for S2, which will be dot 12. Okay. So having done that, let's see what we have in the lab exercise. So the question we have here is, did all devices have successful replies? If not, check your cable and IP configuration. Yeah, so you could see from what we pinged, everything was successful. So we give that a yes. So from the next step, we have from a console connection to S2, enter the show MAC address table command. Okay. So that means we will go back to the terminal, click OK, and come back to S2. So in the S2, you're going to still type show MAC address. Now, when you type the show MAC address, see what we have here. Has the switch added additional MAC address to the MAC address table? If so, which addresses and devices? Okay, so let's see. Previously, we had just this, which we can see here. So 1 out of 4, it means that it has added 3 addresses also. So all you need to do is come here and say yes and take a screenshot and paste it here. So let me just do one part of it, which is to write here as yes. Then you take a screenshot and do that, as you've seen here. So from PCB, open a command prompt and retype ARP space -A. So we are going back to the command prompt. So from the command prompt, we are going to type ARP space A. Now, what can you see? So this is what we have. Remember, the first time we did that, it said no ARP entries found. But in this case, it has updated the MAC address table as seen. Now, does the PCB ARP cache has additional entries for all network devices that were sent pings? So the answer is yes. Now let's go on with the reflection question. So for the reflection question, which will be the last part of this lab exercise, it says on Ethernet network, data is delivered to devices by the MAC addresses. For this to happen, switches and pieces dynamically build ARP caches and MAC address tables. With only a few computers on the network, this process seems fairly easy. What might be some of the challenges on large network? So it's trying to tell us what are the possible challenges we might face for larger networks. So I would say that for larger Ethernet network, it may present a number of difficulties, which include more traffic on the network, and that can contribute to congestion and even poor performance. Data transmission may be delayed, resulting in network latency. So the more devices that are connected to the network, the lesser the overall efficiency. So with more devices to keep track of, managing the MAC address table gets more difficult. Security risks, including proving eavesdropping and others, may expose the network. Also, due to vast size of the network, finding devices and their MAC addresses becomes difficult, and also troubleshooting becomes challenging. So therefore, to ensure a large internet network functions properly, network maintenance becomes more and more crucial. Okay, we've gotten to the end of this lab exercise. So we focused on 7.3.7 lab exercise, where we talked about viewing the switch MAC address table. And I've taken you through the series of instructions and answer all the questions which we are expected to answer. I hope you enjoyed the stay with me. Thank you for staying up to this time. Don't forget to like, share, and to subscribe. And lastly, hit the notification bell so that you'll be notified when I upload my subsequent videos. So I'll be signing off now. Do have a nice time. Bye.